Hello students, welcome back. This is my 15th class on the topic hydrocarbons. In our previous class we have finished with alkenes. Alkenes mugsidvi alva last class alli. In today's class let us start with alkynes. Alkynes. So what are alkynes? Alkynes alli enirutte? They contain triple bond. Minimum ಒಂದು triple bond ಇರಬೇಕು. ಎರಡು ಕಾರ್ಬನ್ ಆಟಮ್ ಮಧ್ಯೆ ಒಂದು ಕಾಂಪೌಂಡ್ ಅಲ್ಲಿ ಮಿನಿಮಮ್ ಒಂದು ಟ್ರಿಪಲ್ ಬಾಂಡ್ ಇದ್ರೆ we call that as alkynes. They are represented by the general formula CnH2n minus 2. The general formula is CnH2n minus 2. So what it indicates? They contain less number of carbon atoms than alkenes. Alkene ginta mattu ಎರಡು carbon atom hydrogen ಏನಿರುತ್ತೆ ಕಡಿಮೆ ಇರುತ್ತೆ, not carbon, hydrogen. They contain less carbon atom than alkene, 2 less carbon atom than alkene. Alkene ಗಿಂತ ಮತ್ತು ಎರಡು carbon atom ಏನಿರುತ್ತೆ ಇದರಲ್ಲಿ ಕಡಿಮೆ ಇರುತ್ತೆ. This is general formula for alkynes. They have wide applications. Alkynes has wide applications, and in today's class we are going to learn its nomenclature and preparation. Okay, first is the nomenclature and isomerism. Nomenclature and isomerism. So how will you name this compound? Alkynes na hege name ಮಾಡ್ತೀರಾ? Corresponding ANE, alkane du ANE ಇರುತ್ತಲ್ಲ, that will be replaced by YNE. Instead of ANE you will write YNE. For example, if the lower member is ethyne, the lower member, if you take CH3 double single bond CH3, what is the name of this alkane? It is ethane. Ethane. So in this CH triple bond, CH will be there. There will be a triple bond between two carbon atoms. So corresponding ANE of the corresponding alkane is replaced by YNE, like this. Okay. Next compound will be propane. Propane. See, I'll write here CH3. CH double bond, C triple bond CH. It contains 3 carbon atom. Root word is prop and the name IUPAC name is propane. Okay, if I take one more carbon atom extra like CH3, CH2, C triple bond CH. What is the name of this compound? How many carbon atoms are there? 1, 2, 3, 4. 4 carbon atoms are here. So 4 carbon atoms. Root word is but. So if you number it 1, 2, 3, 4. At first position triple bond is there. But 1 YNE. This is a IUPAC name. I can write it even like this also. CH3, C triple bond C, CH3. What is the name of this compound? This is also but 1, 2, 3, 4. But 2 YNE. But 2 YNE. It is butane, that means it contains 4 carbon atoms. At second position triple bond is there. So the lowest member of this group is ethyne. Why cannot be methane? Is there any compound named as methane? No. In methane, meth means carbon containing only, or the compound containing only one carbon. Here there should be a triple bond between 2 carbon atoms. There will be only double bond in meth. Single carbon atom in meth. So you cannot form, or you cannot write triple bonds there. So the compound which contains, there should be minimum 2 carbon atoms for both ethene and ethyne. That is for alkenes as well as alkynes. The starting member will contain 2 carbon atoms. Okay. So this is how you will name this compound. what will happen? This will show different isomers. This will show different isomers toorsate. How? Let us check now. If you take butane, butane, see the structure, it is CH3 CH 2 C triple bond CH, another butane CH, this is but 1 YNE, but 1 9 CH3 C triple bond C CH3 but 2 wine. Okay, so see here, what is the molecular formula of this? 1 2 3 4 4 carbon atoms, C4, hydrogen 3 plus 2 5 5 plus 1 6 H6. For this one 1 2 3 4 4 carbon atoms, 3 plus 3 6 hydrogen. Okay, both have same molecular formula, but they differ in position of that triple bond. Triple bond position is different. Here on first carbon atom triple bond is there. Here on second carbon atom and between second and third carbon atom triple bond is there. So these two are position isomers. What are position isomers? They will be having same molecular formula, but the position of double bond, triple bond or functional group will be different. They will be present at different carbon atoms. Here double bond, in first case triple bond is present in between first and second carbon. In second case triple bond is present in between second and third carbon atom. Alva? So these two are example for position isomers. First, ethane and propane, they will not show any position isomers. Only one structure is possible for that. You cannot write different structures for them. But here, different structures are possible. You can change the position of triple bond. So, which leads to the formation of different compounds. In Sigata, different compounds, their structures will be different. If I take pentine, or if I write one more structure for this butane only, so it is like this CH, not here, CH2, CH3. If I write this structure, if I take pentine, I cannot write for that, this one. If I take pentine, so can you write different structures for pentine? Yeah, it is pentine means it contains 5 carbon atoms, CH3, 1, 2, 3, 4, 5, H, CH2, CH2. So this is, the name of this compound is pent 1-ine. Pent 1-YNE. I will write one more compound, that is CH3, CH2, C triple bond, C, CH3. What is the name of this compound? Pent 2-YNE. Okay, I will write one more structure like this. CH3, 3, 4, CH3, CH, yeah. What is the IUPAC name of this compound? 1, 2, 3, 4, 3 methyl, or this is methyl butene, but1-ene. Okay, 1, 2, 3 methyl but1-ene. This is 3 methyl but1-YNE. I told ENE, that's not ENE, YNE. Okay, see. The molecular formula of this is 1, 2, 3, 4, 5 carbon atoms, C5, hydrogen, 3 plus 2, 5, 5 plus 2, 7, 7 plus 1, 8. C5H8. This one 1, 2, 3, 4, 5. 5 carbon atoms. 3 plus 2, 5. 5 plus 3, 8. Same molecular formula. See here. If you see this 1, 2, 3, 4, 5. 5 carbon atoms. 3 plus 3, 6. 6 plus 1, 7. 7 plus 1, 8. Same molecular formula. All these have same molecular formula. These compare these two compounds, first compound and second compound. What is the difference? Only in position of triple bond. Both are straight chain compounds. They differ only in position of triple bond. Position enagide triple bond change agide ashtene. So these two are example for position isomers. I took an example of butane last time. So 2 minutes before, now it is pentane. They show position isomers. Now compare structure 1 and 3. 1 and 3. See, it is a straight chain, it is a branched chain. So these two are example for structural isomers. They show different structural formula. Yenide chain isomers ke example there. So not structural, chain isomers. All these are structural types of structural isomers. Okay. So this is chain isomer. These two are position isomers. If you take 1 and 3, 1 and 3 consider madi, yenagide contains a branched chain, it is a straight chain. Both have same molecular formula, but the chain length is different. In one, there are 5 carbon atoms are in straight chain. In this one, only 4 carbon atoms are in straight chain. One is a branch. Okay, if you consider 2 and 3, here also same thing. They also pose example for these two and these two are examples for chain isomers. The chain length is different. The chain length is different. So as you proceed, you will get around 6 isomers for pentene, I think. Calculate them, write them and find which one are chain isomers, how many chain isomers are there, how many position isomers will you get, check it, okay. So that is about nomenclature and isomerism. It shows mainly 2 types of isomers. First one is chain isomer and second one is position isomer. Next is structure of triple bond. Structure of triple bond. Structure. How triple bond will be formed? Structure of triple bond. Hege formation agate triple bond. See, if I take ethine as example, I will take ethine. Ethine contains 2 carbon atoms. C triple bond C H H. Okay, this is ethine. In ethine, carbon undergoes, in all the alkynes, carbon which is bonded to triple bond will, or which is present next to triple, which are joined through triple bond will be sp hybridized. The carbon atom in alkynes are sp hybridized. They undergoes sp hybridization. The hybridization will be sp. See, it contains how many hybrid orbital? sp hybrid orbital. That means each carbon contain 2 hybrid orbital. Among that 2 hybrid orbital, 1 hybrid orbital will overlap with sp hybrid orbital of other carbon atom. This is 1 hybrid orbital of 1 carbon atom. See, I will write like this. This is 1 hybrid orbital of 1 carbon atom and this is another sp hybrid orbital of another carbon atom. Okay. So, carbon atom will be present here. It contains 2 sp hybrid orbital. There will be, in case of ethane, there will be 1 more carbon atom that also contain 1 sp hybrid orbital and another sp hybrid orbital like this. So carbon will be present here. So Head-on overlapping of these two orbital will lead to the formation of sigma bond. Head-on overlapping of sp orbital of two carbon atom leads to the formation of sigma bond. Sigma bond formation aitu. See, this is sp orbital of one carbon atom and this is sp orbital of another carbon atom. They will overlap to form sigma carbon-carbon sigma bond. Carbon-carbon sigma bond formation will take place. Okay. Next, one more sp hybrid orbital is there on both the carbon atoms. They will overlap with s orbital of hydrogen. This is s orbital. This is sp hybrid orbital. These two are sp hybrid orbitals. And remaining sp hybrid orbital of both the carbon atom will combine with s orbital of hydrogen to form carbon hydrogen sigma bond. This leads to the formation of carbon hydrogen sigma bond. Okay, how many sigma bonds are present? 1, 2, 3. 3 sigma bonds will be present in ethine. Okay, see here. It will be like this. C, single bond C, H, H. Now this is over. This carbon contains unhybrid orbital. Unhybrid, two unhybrid p orbital will be present. Okay, carbon contains unhybrid p orbital. Two unhybrid p orbitals will be there. One unhybrid p orbital. For this also one unhybrid p orbital and one more unhybrid one more unhybrid p orbitals on both the carbon. Both the carbon atoms contain two unhybrid orbitals. There exists already one sigma bond between these two and hydrogen. So what will happen? This is 2px and this is also 2px. This is 2py, 2py. So they will overlap. Overlapping of this will take place. 2py and 2py will overlap above and below the plane like this, and 2px will overlap with 2px. This will lead to the formation of pi bond. Two pi bonds will be formed by the overlapping of two unhybrid p orbitals in case of carbon. Carbon contains two unhybrid p orbitals which forms two pi bonds. Okay, so your ethine contains one carbon-carbon sigma bond, two carbon-hydrogen sigma bond and two carbon-carbon, that means two pi bonds. Okay, this is structure of triple bond. Okay, this double bond is stronger than, triple bond is stronger than double bond. So triple bond is more stronger. Triple bond is stronger, or I write triple bond is more stronger than double bond, which is more stronger than single bond. So as it becomes, and it will be shorter in length too. Adradu length kuda enagirutte shorter irutte compared to double and triple bond. This is strength. Strength will be greater. It has more strength than double and single bond, and even it is shorter. It is shorter than double and triple bond. Double matte triple bond ginta enagirutte idu shorter agi irutte. Okay, this is about structure of double and structure of triple bond. So what we have studied? So alkynes they contain minimum one carbon-carbon triple bond. Its general formula is CnH2n-2. Remember this. And we have studied the nomenclature. Ane of the corresponding alkane is replaced by Yne. It shows mainly two types of isomers, position isomers and chain isomers. In case of position isomers, triple bond will be present at different positions, Chain isomers is nothing but in some will be in straight chain, some contains branched chain, but their molecular formula is same. They will have same molecular formula, different chain lengths will be there. Next is structure. Structure is important. Carbon undergoes sp hybridization. In ethyl, carbon undergoes sp hybridization. One sp hybrid orbital of carbon will overlap with another sp hybrid orbital of another carbon to form carbon-carbon sigma bond. The remaining sp orbital of both the carbon atom will overlap with s orbital of hydrogen. In case of ethine, they will overlap with s orbital of hydrogen to form carbon-hydrogen sigma bond. Carbon-hydrogen sigma bond formation agutte. Next, these two carbon atoms contain unhybrid p orbital. Each carbon contains two unhybrid p orbital. So what it will do, that unhybrid p orbitals will overlap to form pi bonds. Okay, these pi bonds are triple bonds are stronger than double as well as single bond, and the pi bond, but they are shorter in length. They are shorter and stronger. Okay. Thank you. Let us continue in next class about preparation and its properties.